When we're solving, it doesn't matter which method you use to solve it. You can typically use factoring or quadratic formula, the two we've gone through. Either way, we need to know what A, B, and C are. So A is 1, B is 2, C is 17. I like to check out factoring first, because if we can factor it pretty easily, it actually goes by pretty quick. So we have 17 and 2, so two numbers that multiply to 17 add to 2. Only thing I can think of that multiplies to 17 is 1 to 17, which does not add up to 2, which means we're going to just default to the quadratic formula. So we have x equals the opposite of b, plus or minus square root b squared minus 4ac. Make sure whenever you plug anything in, you're putting it in parentheses. Make sure that extends all over 2 times a. So we're going to start simplifying things. So we have negative 2 here, plus or minus. For the square root, put everything inside the square root into a calculator. Makes our lives a bit easier. This would give us negative 64, all divided by 2. So we're going to simplify that square root of negative 64. We're going to take out our I. We check, is 64 a perfect square? It happens that it is, so we get 8i. So we're going to take that, replace it back in. So we get x equals negative 2 plus or minus 8i over 2. So we look at these three numbers now. The 2, the negative 2, the 8, and the 2. And we said they all have a 2 in common. So what we can actually do is we can divide all of those numbers by 2. So divide by 2, divide by 2, divide by 2. So we get negative 1 plus or minus 4i. 2 divided by 2 is 1. If you want to write divide by 1, you can. But dividing by 1 doesn't change it, so we don't have to write it. But if you do, it's fine, it's not wrong. So what we want to do now is just separate this into 1 with a plus. So negative 1 plus 4i, and x equals negative 1 minus 4i. These are not like terms, so we cannot combine them. So we are done with number 12. There are two answers. For 13 it says solve by factoring, but if you don't want to use factoring, go ahead and use a quadratic formula, 100% okay. But we're just going to go through how to do this one with factoring. So whenever we have this number in front, we don't want that. So we're going to take it, slide it down, those are going to get multiplied. So x squared plus 10x plus 21 is 0. Okay, this is factoring only when we do this. So we have an a of 1, b of 10, c of 21. We have our big X, 21 on top, 10 on the bottom. Just like before, c on top, b on the bottom. So two numbers that multiply to 21 add to 10 would be 7 and 3. So we get x plus 7 and then x plus 3. With factoring, you have to remember we slid this 7 down before, which means we have to divide it out now. So both these numbers get divided by that 7. So 7 divided by 7 can reduce to 1, so we get x plus 1. We can't reduce 3 over 7, so we take this 7, put it in front of the x. 7x plus 3. So if we just wanted to factor, we'd be done. But since we want to solve, we have to figure out what those x's actually are. So x plus 1 equals 0. 7x plus 3 equals 0. So over here we subtract 1. We get x is negative 1. Over here we subtract 3. Since we still have 7x, we divide both sides by 7. And we get x equals negative 3 over 7. And then we have our two answers. Again, if you want to use quadratic formula, you'll still end up with these two answers in the end. It just depends on personal preference on how you want to solve it. Okay, one last solving one. So I noticed already that 9 and 81, if I multiply those, I'm going to get really big numbers. So I'm going to do quadratic formula. So a is 9, B is 0. It's not negative 81 because there's no x term. And then C is negative 81. So I'm going to go ahead and plug it in the quadratic formula. I'm going to pause while I do that. So everything's plugged in the quadratic formula. Negative 0, we don't need that because it's 0, so we just have plus or minus our square root. And again, just put all that in the calculator. Makes our life a bit easier. So this we're not sure of if it's a perfect square or not right away, because that's a really big number. But if we check it in the calculator, it turns out that it is, which makes our life pretty easy. So we get positive or negative 54 over 18. So we're going to split this up once, where it's positive 54 over 18, and again when it's negative 54 over 18. So a couple different ways of reducing this. You can figure out the greatest common factor divided out. In your calculator, if you divide it, it will give you the answer. Sometimes it's really nice. In this case, if we do 54 divided by 18, we just get 3. Over here, we do negative 54 divided by 18, we get negative 3. So we have our two answers for this one. So positive 3, negative 3. So question number 15 asks, which of our equations in the last three example had complex solutions? Okay, so complex solution has an I. So complex solution has an I. Means it's a complex number. So you could have a square root in your final answer, but it's not complex because it does not have an I. So you only had one question that had the I in it, which was question number 12. So which equations in problems number 12 through 14 produce complex solutions? You can just tell me the question number that it was. Explain would pretty much be this. We found our solutions, they had an I in it, that makes it complex. That's all I'm looking for on this.